Hello student, good morning to all of you. Today we are going to derive the formula for Bohr's atomic model of hydrogen. In this, Bohr assumed that an electron is revolving around the nucleus, and in his postulate the centripetal force is provided by the electrostatic force. Therefore, both the forces are equal. We discussed in the previous class. Now, we applied here the postulate 1, that is centripetal force Fc is equal to electrostatic force. So student, we have centripetal force is mv square upon r and electrostatic force is 1 upon 4 pi epsilon naught electron, charge on electron and charge on nucleus. We use E and E square upon distance r square. Clear? Now, on solving this, we calculate here that this r cancel by this square, so we calculate for first v square, that is E square upon 4 pi epsilon naught m r. This is equation first, and for radius r is equal to m r is equal to, ये हम यहाँ से क्रॉस मल्टीप्लाई कर लेंगे, that is e square upon 4 pi epsilon naught mv square. This is equation second, which calculated by Bohrs by using the concept of centripetal force. This is also calculated by the Rutherford also. Now, this is by the first postulate, and now by the second postulate. The second postulate of the Rutherford is Bohr is the electron is only allowed to revolve around the nucleus for a specific orbits in which the orbit have the certainty that h upon 2 pi. For n electrons, the angular momentum is nh upon 2 pi. So we are calculating it by the second postulate. By the second postulate, L is equal to nh upon 4 pi, but in circular motion the momentum is m Rn Vn. Here student, Rn and Vn are, Rn is the number of radius of nth orbit and Vn is the velocity of electron in the nth orbit. Now, by comparing the two, we get NH, or we say mRn Vn is equal to nh upon 4 pi. Now we calculate from here the radius of nth orbit and radius of and velocity of nth orbit. So we can derive radius Rn is equal to nh upon 4 pi mvn. Here now we have the value of Vn from here, that is nh upon 4 pi epsilon naught m under root students, the angular momentum is nh upon 2 pi, not 4. Now we can calculate the from here radius Rn is equal to nh upon 2 pi mRn and velocity Vn is equal to nh upon 2 pi mRn. Okay, now on putting these value in equation first and second, now from equation first and second we get v square is equal to e square upon 4 pi epsilon naught m, and the value of r is nh upon 2 pi m Rn. On solving this, or we say till this point, we can calculate it as e square upon 4 pi epsilon नॉट, m से m कैंसिल हो जाएगा, and we get h upon 2 pi Rn 1 upon n. Now from here we calculate that the v square is inversely proportional to 1 upon Rn. Now this Vn cancel the square of this, so we calculate the velocity of electron in nth orbit is the multiple of 1 upon nth time. Now Rn is equal to, from equation second, e square upon 4 pi epsilon naught m, and v square has value e square upon 4 pi, 1 minute, इसमें वैल्यू रख रहे हैं हम, तो ये तो हमने लिख लिया. नाउ द वैल्यू ऑफ r as has value 1 minute, r v square, so v has value this. On putting this value here, we calculate that n square h square upon 2 pi m r n, ये सब स्क्वायर है. और भी से होल स्क्वायर. ओके, नाउ when we solve it, we get e square 4 pi square m square rn square upon 4 pi epsilon naught n square h square. Now here this rn cancel by the square, so we calculate for rn, radius of nth orbit, that is, okay. Now see student, from here this 4 cancel this pi cancel this square, so we get pi epsilon naught n square h square and e square m square. Anything else? This we have the value of r. Now from here we find that the radius of nth orbit is directly proportional to the square of the radius. Okay, now we going to calculate that. Now copy till this point, then we derive the condition for radius, condition for the energies. Okay, energy of electron. Electron has both kind of energy. One is kinetic energy, that is given by half mv square, and we have the value of v in nth orbit, that is v square. This we have the v square. Okay, so half m, and we have v square is e square upon 4 pi epsilon naught m r. Now here this m cancel by this, and we calculate the kinetic energy. Kinetic energy is e square upon 8 pi epsilon naught r. This is equation 2. This one is 3. This one is equation 3. this is equation 4 and this is equation 5. Now potential energy is minus because it is always attracted towards the nucleus, so it is taken as negative, is from the electrostatic 1 upon 4 pi epsilon naught square of charge upon r. So we calculate that the potential energy is E square upon minus E square upon 4 pi epsilon naught r. Therefore, total energy of electron, total energy, total energy is E is equal to kinetic energy plus potential energy. On putting the values, we get energy of nth orbit is 8 upon 4 E square upon 8 pi epsilon naught Rn and minus E square upon 4 pi epsilon naught Rn. On taking LCM, we get energy of nth orbit is minus E square upon 8 pi epsilon naught Rn. Okay students, copy till this point. Then after we put the value of Rn in the energy, which gives us the energy of electron at in the nth orbit. So first copy till this point. Then we are going to derive the okay. Okay. Now, on putting the value of R, En equal to become minus E square m upon 8 pi epsilon naught n square h square. By this formula, energy of nth orbit is increased by the ratio this value. Okay. on putting Rn is equal to n square upon m h square upon 2 pi 4 pi epsilon naught upon e square. By putting this value we get this relation after putting. Now energy of ground state of hydrogen atom. By this formula the energy of electron in the closest orbit for n equal to 1 is calculated as E n is equal to minus 13 minus 13.6 electron volt. This is energy of electron in the ground state. Copy till this point. By putting some energies for the constant like charge on electron, mass of electron, pi, epsilon naught and h square Planck constant, we get En is equal to minus 2.18 into 10 to the power minus 18 upon n square j joule. Okay, so the energy of ground state E1 which we calculate for n equal to 1 is minus 13.6 electron volt. Energy of ground state for n equal to 2, the same value is divided by 2.18 into 10 to the power minus 18 by square of 2 is 4. It is calculated as minus 3.4 electron volt, energy of first excited state, energy of first excited state. Next, E equal to 3, it will calculate it as minus 2.18 into 10 to the power minus 18 by the square of 3 is 9, and this result is comes to minus 1.51 electron volt. This is energy of second excited state. Excited state. Similarly, for putting E equal to 4 minus 2.18 into 10 to the power minus 18, square of 4 is 16, is point minus 0.85 electron volt. This is for the energy of third excited state, and for last E equal to 5 minus 2.18 into 10 to the power minus 18 upon n equal to infinite is this, and this result goes to 0 electron volt at the top state, or we say unbounded energy state. Okay, so copy all these points of energy levels. In the next class we are going to discuss on the line spectrum of hydrogen energy, which the electron radiates out the energy when it is jumps from ground state to the first state or any other states. Okay. Now, wavelength of nth orbit. By using the third postulate of Bohr's, according to the third postulate, the difference of energy levels from one state to the other is given by h nu is equal to E initial minus E final. We have energy minus E square upon 8 pi epsilon naught h nu is equal to 8 pi epsilon naught n square h square. Here we use n is initial and minus E square upon 8 pi epsilon naught h square nf square. Okay, now this will become positive and we are taking common from this point. Nu is equal to E square upon 8 pi epsilon naught h square, and this h multiplied to become h cube, and in the bracket 1 upon nf square minus 1 upon ni square. Clear? Now on putting value of nu is frequency or time, so we get c upon lambda in place of nu. By putting this, we get c upon lambda is equal to e square upon 8 pi epsilon naught h cube upon 1 upon nf square minus 1 upon ni square. Okay, now this c multiply here, we get 1 upon lambda is equal to e square 8 pi epsilon naught ch cube is 1 upon, फाइनल के लिए यूज करेंगे स्टूडेंट, ओके, nf स्क्वायर माइनस 1 अपॉन ni स्क्वायर. ओके, नाउ दिस वैल्यू इज कॉल्ड रिडबर्ग कांस्टेंट. Therefore 1 upon lambda is equal to RH 1 upon nf square minus 1 upon ni square. This is the formula for wavelength of the energy radiated, where RH is equal to E square upon 8 pi epsilon naught ch cube. When we put all the values, we get 1.01 into 10 to the power 7 meter inverse. This is a universal constant and known as Rydberg constant. Okay, so calculate till this point, and from this point we are explain the line spectra of the hydrogen atom. This is all about the Bohr's atomic model. Then after we are going to understood about the line spectrum, which are parallel to each other, and the spectrum have 5 series: Lyman series, Balmer series, bracket, Paschen, Fund and bracket. We are discussed in the next lecture all these series. Thank you.